Hi everyone, welcome to my final year project FYP presentation. My name is Amli and this presentation about development of machine vision system for automatic size detection. In this presentation, I will cover starting from the introduction, then to the significance of my project and the objective of my project. Then I will go a little bit about the vision-based system. Then I will explain on the methodology that I use and I will present to you the result from my project and I will conclude it in the conclusion. Do you know 80% of Malaysian smartphone user actually opt the online shopping platform? The world itself is entering the Industrial Revolution 4.0, IR 4.0, which is more to the automation and data exchange. And due to the COVID-19, this thing actually create a demand, especially to the big companies like Amazon, which is stated in their report with the demand on the online shopping trade rocketing to about 50 million boxes per day from 10 million boxes. This trade actually demanding on many industrial to apply the smart logistic to handle numbers of boxes by using the S of the artificial intelligence AI. Using AI, a vision system can be applied into industrial use to help handling the hard work load. A machine vision is an image-based technology that using image processing technique to extract information. This kind of technology actually already been used in automotive and manufacturing, electronics, semiconductor, food and packaging, and also in general manufacturing. Through the use of the machine vision, we can automatically detect the object size. And through that, we can use robotic arm or automatic optimization for box arrangements via the data that we obtain from the vision system. This can greatly reduce workload that originally require human power. These are the existing technology used in the factory, which are mostly using the sensor technique. However, as said, these are sensor. When we are talking about sensor, it's difficult for us to control the sensors, while the accuracy also inconsistent. It's difficult to manage sensors because they are sometimes too small and sometimes we need to handle it with care. The maintenance also require high cost. It's really expensive and also some of the sensors require human surveillance. Therefore, in my project, I'm focusing on something which is due to the rapid growth of the logistic company, we need to develop something to tackle this issue to help the autonomous machinery, which this can increase the productivity and operational efficiency. Many research have been done, so I'm going to do this research also to help in developing high accuracy, low cost, and easy to use machine vision system. The importance of my research is to have a better image quality and resolution. The outcome will be the accurate, fast processing time, easy to control and manage, and lastly, is really cost efficient. The significance of this project will be my project will be totally different from the existing. Most of the existing machine vision system are focused on the object. My system will be focusing on the background area instead, and then I will be referring to the one reference lines. From this, I can ensure the accuracy and the stable algorithm. I am going to test it with the pre-existing system to prove my system performance. This objective of my research are to develop an automatic machine vision system for box size detection in 3 dimensions using a single lens reference with a single perspective image only. Then I'm going to test the system algorithm accuracy by utilizing the use of single line for the data extraction. Lastly, I'm going to compare with the previous existing system for developing accurate and balanced system. These are a little bit review on the existing studies done on this vision-based system. As you can see, there are various type of the technique used. Let's say the first one from Gongle, they are focusing on the color space. The Nyalala are using the sensor and the color space. Shahib utilizing the time of flight sensor of infrared, combining with the machine vision system. And the last two are using the deep learning technique, using the structured line and line triangulation. From the pre-existing system, there are 6 common technique, which is using the method of pixel size, grid counting, etc. However, as you can see, there's actually from this system only one, which is the second one. Tay and Khairuddin are using the background-based technique, which is they are focusing on the background instead of the object. And their method actually a grid counting with the accuracy of 94.3. I'm going to do my project and compare with this project. This is the summary of the systems available today. My system will be focused on the most right side with the orange boxes. That technique I will going to use as a morphology, Hood transformation, mathematical calculation, and triangular similarity. For the method that I use in my study, there are 3 things I will focusing on. First, about the image acquisition and pre-processing technique. This algorithm focuses on the pre-processing of the image. Then, the edge detection algorithm for the image segmentation and feature extraction. And lastly, the dimension estimation and calculation. This to compute the dimension of the boxes. This is the flow of the execution for my algorithm. Starting from the image acquisition, I will start from the image acquisition, followed by the pre-processing. Then I will go to the segmentation process to using the edge detection, and I will going to extract the information. Through the information extracted, I'm going to compute to the mathematical formula to estimate the dimension of the boxes. And lastly, I'm going to manually perform analysis on the system performance. As you can see, there are 3 stages of my system. Starting from the stage 1, which is the background preparation. As I said, as I did this project, I will focus on the background of the image. Therefore, I need to fix the background. So, for the stage 1, I need to carefully prepare the background and install it and set up the camera with a fixed distance and conditions. For the stage 2, the same as previous, which is this is about the programming algorithm, starting from the image acquisition until the volume computation. And lastly, the final stage is to check the performance of my system. With I'm going to do a manual calculation followed by result comparison, map analysis, which is mean absolute percentage error, and lastly the accuracy check. Let's talk about the image acquisition and pre-processing. In this stage, there will be 40 images that I'm going to read using my algorithm. And then these images will undergo grayscaling process to change the color space from the RGB to gray image. Lastly, I'm going to filter to reduce the noise and smooth the image before undergo the segmentation process. These are the image. Starting from the left is the original image, and the most right side actually the best image after pre-processing. For the image segmentation and feature extraction, I'm going to start with the thresholding. I'm going to use the binary thresholding algorithm to isolate the object and the platform, followed by the edge detection. Edge detection, I'm going to use the Kenny edge algorithm to be applied on the image to find every edges of the boxes within the image. Lastly, I'm going to use the Hood transform to find and predict the line within this image. These are the 3 output of the image. The most left is the binary image. The middle one is using the Kenny edges. And lastly is the Hood transformation. For the dimension estimation, as you can see, there are 3 things that I need to do. Mathematical calculation, contour approximation, and triangular similarity. The outcome will be on the right. As you see the image, I can find every edges. Through the mathematical calculation, I can compute the width, height, length, and also the volume of the boxes itself. These are the results from my project. This table shows the error. As you can see, the green shows the best output with the least error, and the red one shows the most error. The error mostly lies on the length. When this also affected by the object placement, either by on the side of the platform or at the center of the platform. As you can see, the best position to get the most accurate result actually when the placement is at the center, and the best dimension is detected actually the width of the object. The conclusion, I can say that my image processing can compute box dimension without exceeding 1000 millisecond. That means in less than 1 second itself. My system has the high accuracy result on dimension of the boxes, especially on the width and the height of the object. I can say that this system is a stable system with the accuracy achieved 94%. This system is an enhanced algorithm with ready-to-use system after I review most of the existing algorithm. This is the automatic size detection using only a single camera and a reference line. I'm going to share with you my project demonstration. As you can see in my screen, these are the code that I use for my project. I set here, example, I'm going to read image 40. Then I'm going to execute this code to show the output. As you can see here, these are the output, the same as you can see in the slide. And I'm going, during this project, I need to run several times, for 40 times, for all the images. And this image actually take about 1 second only. So I think that's all for me for the project demonstration. These are the paper that I refer to and I cite in my project. Thank you. Hope you like and can give me a thumbs up for my project.